Hello everyone. Today we shall study the chapter Solutions, that is in your Chemistry NCERT book class 12. Okay. So as per new syllabus, this is your first chapter, but here it is written unit 2 because this is an old version of NCERT book. So let's start. In normal life, we rarely come across pure substances. So at first we should know what are pure substances. So pure substances are the substances that have fixed chemical composition. Now what does this mean? So let's take an example of water. 1 glass of water. Precisely if I say 1 glass of distilled water. What is the formula of water? We know it is H2O. Right. So in that distilled water, no other minerals or ions are present. So definitely this is an example of pure substance. That is, only H2O molecules are there. Okay. Most of these are mixtures containing 2 or more pure substances. In the first line, as we have seen, in normal life we rarely come across pure substances. So what we come across? Mixtures. So most of these are mixtures containing 2 or more pure substances. Let's take another example. Suppose mineralized water. Okay. So it contains different types of minerals in it. As we know that calcium ions can be present, magnesium ions can be present, and other ions. Okay. For example, their utility or importance in life depends on their composition. So definitely there is an importance of these mixtures. Let's take the same example of that mineralized water. So mineralized water contains minerals, and we know that these minerals are very much important for our growth and development. So this is the utility. For example, the properties of brass, mixture of copper and zinc, are quite different from those of German silver, mixture of copper, zinc along with nickel. Okay, or bronze, mixture of copper and tin. So now what are these? Brass, German silver, bronze. What are these? These are called alloys. Now what are alloys? Alloys are homogeneous mixture of 2 or more substances. Now what are these substances? These substances can be metals, non-metals, that is metals and metals, metals and non-metals, and etc. Now this brass, German silver, bronze, they have some importance definitely. This brass is used for making locks, hinges, gears, etc. German silver are basically used for making ornaments, tableware, decorative articles, etc. Bronze are also used for making ornaments, that is jewelries. So these are their utility. Okay, now 1 part per million ppm of fluoride ions in water prevents tooth decay. Now what does this mean? This ppm term we will learn in this chapter in details. So let's learn what is this. So 1 part per million. So in million, how many zeros are there? 1, 2, 3, 4, 5, 6. 6 zeros are there in 1 million, we know. Okay, so 1 part per million means 1 part of 1 million. Okay, so 1 part per million of fluoride ions in water prevents tooth decay. That means in suppose in a glass of water, just take an example. Suppose in a glass of water, 1 million water molecules are there, and in that only out of 1 million water molecules, there is only 1 part fluoride ion. While 1.5 ppm causes the tooth to become mottled. Now what does this mean? We are increasing the part per million value, that is from 1 to 1.5 causes what? Tooth to become mottled, that is damaged. Okay, and high concentrations of fluoride ions can be poisonous. For example, sodium fluoride is used in rat poison. So when 1 parts per million of fluoride ion is there, it is beneficial for us, that it prevents tooth decay. But as soon as we increase the concentration from 1 to 1.5, it causes tooth to get mottled. And high concentrations of fluoride is used, high concentration of fluoride ions can be poisonous. For example, sodium fluoride is used in rat poison. So definitely if it is hazardous for rat, definitely for human beings also it will be hazardous. Okay. For example, sodium fluoride is used in rat poison. So what is the formula of sodium fluoride? NaF. That is, it is formed by Na plus, that is sodium ion, and fluoride ion. As we know, this is an ionic compound. Okay. So now intravenous injections. Now what are intravenous injections? Intravenous injections are the injections that are directly injected to our vein. Okay, so intravenous injections are always dissolved in water containing salts at a particular ionic concentrations that match with blood plasma concentration and so on. Now what does this mean? The intravenous injection solutions that are being injected to our blood should always maintain the same ionic concentration as that of blood plasma. Otherwise, if the concentration is different, suppose the injection that will be introduced in our body have a different concentration than that of blood plasma concentration, the consequences are going to be severe because both the concentration is different. That's why always dissolved in water containing salts at a particular ionic concentration that match the blood plasma concentration. So both the concentrations should be same, then only we can inject that intravenous injection to a human body. Okay. Now in this unit we shall consider mostly liquid solutions and their formations. So we will deal with basically liquid solutions. This will be followed by studying the properties of the solutions like vapor pressure and colligative properties. We will begin with types of solutions, see here, and then various alternatives in which concentrations of a solute can be expressed in liquid solutions. So these are the topics that we will discuss in this chapter. Okay, so let's start with types of solutions. Solutions are homogeneous mixture of two or more than two components. So this is very important to know what are homogeneous mixtures. First, let us know what this term signifies. Homogeneous term means what? Homogeneous means uniform. Okay? Means solutions are the mixtures of two or more components that will form homogeneous mixture. Okay. This means, again let us take the example of water. In water, we are adding 1 teaspoon of salt. Okay. Now, we are stirring it. Why we are stirring it? So that the entire salt get dissolved in the water. Okay. This is called making of homogeneous mixture. Okay. After the salt completely dissolved in the water, that will be called as homogeneous mixture. Okay. That means in the entire water, at every portion or at every part of the water, the salt is being mixed. Okay. By homogeneous mixture, we mean that its composition and properties are uniform throughout the mixture. As I said, by the example of salt in water, that it will be uniformly distributed. Okay. So by homogeneous mixture, we mean that the composition and properties. Composition is okay, that formula of salt is, that is table salt, is NaCl. That NaCl will be mixed in that entire water. Okay, now what about the properties? What is the property of salt? The physical property of salt, that is salty taste, right? So if we do not mix it properly, often it happens that when we drink that water, the upper part of the water is not that much salty in compared to the bottom. That means it is not a homogeneous solution because the entire salt has not been dissolved in the water. Okay. Now, generally, the component that is present in the largest quantity is known as solvent. Suppose we are taking an entire glass of water and we are taking a tablespoon of salt. So definitely the entire water volume is more. Okay. So I mean the quantity is more in compared to the salt, right? In this unit, we shall consider only binary solutions. So what are binary solutions? Let's see. That is consisting of two components. So binary solutions are the solutions in which there are two components. Now what are these two components? One component is the solvent and another is the solute. Okay. Here each component may be solid, liquid or in gaseous state and are summarized in table 2.1. Okay, so types of solutions. First type of solution. First type is gaseous solutions. Solute is gas, solvent is gas. Mixture of oxygen and nitrogen gases. As we know, in our atmosphere, 78% nitrogen is there and near about 21% oxygen is there, and the rest are other gases. So this is one of the example of mixture of oxygen and nitrogen, that is gaseous solutions. Liquid solute and gaseous solvent, that is chloroform mixed with nitrogen gas. But chloroform is a liquid, how will it mix with nitrogen gas? See, chloroform is a volatile liquid. Now what is the meaning of volatile? Volatile means easily it gets evaporated. Okay. So that's why chloroform will mix with nitrogen. Again, see, solid solute and gas solvent. Camphor in nitrogen gas. As we know, camphor easily gets sublimated, right? So camphor in nitrogen gas is an example of gaseous solution. Next is liquid solutions. Gas is the solute, liquid is the solvent. Oxygen dissolved in water. As we know, our aquatic life is alive due to this concept that oxygen gets dissolved in water. Liquid solute, liquid solvent. Ethanol dissolved in water. Maximum cases we see that from a concentrated solution, or suppose concentrated acids, we are diluting. So what we are doing? We are adding acid to that water. So in that concept, acid is the solute, that is a liquid solute, and water is also liquid. So liquid solutions. Another example is dilution of acids. Okay. Ethanol dissolved in water is also same. We are dissolving ethanol into water. So the quantity of ethanol is less and water is high. That's why it is solute and this is liquid. Simple. Solid liquid, that is solid solute and liquid solvent. Glucose dissolved in water or sugar dissolved in water, right? Solid solutions. Gas solid. Solution of hydrogen in palladium. Now this can be confusing for you, that how gas can get soluble into solid. See, this is a concept basically called occlusion. No need to know now, just memorize it for this level, that solution of hydrogen in palladium. Okay. Liquid solid. Amalgam of mercury with sodium. This we all know, that if mercury or mercury is there and we are making any kind of alloy using mercury, we say it amalgamation, right? So when liquid solute and solid solvent is the example is amalgam of mercury with sodium. Solid solute and solid solvent. Copper dissolved in gold, right? As we know that pure gold is of 24 carat. What we do? We add copper like substances to reduce its carat value, because so that we can use it for jewelry, as 24 carat pure gold is not that much hard. So that's it for today. Please subscribe the channel and hit the bell icon. Thank you.